Hello everyone, welcome to the physics simulation. So here we have today we'll study about magnets and electromagnets. So we first see about the magnet. So this is the bar magnet. I'll just click on this bar magnet. So here we have this option of changing the strength of the bar magnet. So if we can start from 0 up to 100%. When it make it 0, we can see there is no magnetic field around this. So when we just go on increasing the magnetic field, what happens is we can see the magnetic lines of forces. When we increase it, they are making more and more intense. So we can even see inside the bar magnet that this is the magnetic field. So here we have this is the compass. So when we keep north around here, the south pole it gets attracted. If I take it up, this is how we get it. Okay. We can even measure the magnetic field here. Okay. So this is the magnetic field. This is the magnetic field B. This Bx is the x component, By the y component. We can just move around. We can see the change. We can see the changes around it. Okay. We can even flip the polarity. Here we can see the polarity. South becomes here. South is this and north is this. Now this is about the bar magnet. Now let us study about the electromagnet. So this is the electromagnet we have. Okay. So this electromagnet is a magnet which actually, when electric current is passed through it, it becomes a magnet. It is not a permanent magnet. So here what we can do is we can just change the flow of current. Either we can have 0 volts, so nothing flows through it, so it is not acting as a magnet. Okay. So if we give the positive voltage, so this is the flow of current which it shows, and if we apply the Fleming's right hand rule, so what we see, this is the direction of the magnetic, this is the direction of the this you can see the flow positive charges. So it shows the flow of electric current, and this shows the direction of magnetic field. So when you bring this is what we get. If I inverse the polarity, the current flows in opposite direction, and you can see this changes. Just see this changes the direction of this needle changes. Okay. And one more thing what we can do is we can have this number of loops are 4. So if we can even have this field meter here. So what we observe is with 4 loops we have this, the reading as 1.449 Gauss. So if I decrease the number of loops, okay, you can say this goes, it decreases. Okay. So if I increase the battery voltage, the current, we get more current and the field increases. Now if I make it 1, it is 2.43 Gauss. If I increase this, the magnetic field increases with 3 loops. You can see these 3 loops, magnetic field increases, and with this it increases more further. So this is how what we see is electric current flowing through a coil. It produces a magnetic field around it, and this is what we have seen. And it depends, this magnetic field, it depends on the electric current and also the number of loops. So that's what we can study from this. So that's all for this session. Thanks for watching.